Hey guys, this is Mr. Mood. Today we're going to talk about the different ways to represent a function. At the end of this lesson, you'll be able to take a function in any form and represent it as ordered pairs, a table, a graph, and a mapping diagram. In all, there are 5 ways to represent a function. We have ordered pairs, a table, a mapping diagram, which is new, and a graph. Now there's one more that we're not going to talk about today, and that's going to be an equation. On this page we have all the different forms of a function listed out. And what I'm going to do is I'm going to draw an arrow between all the different representations that you can use to create one another. So as you can see, I can either go from ordered pairs to a graph or backwards, from ordered pairs to a table or backwards, or from ordered pairs to a mapping diagram or back. And you notice on here I also have the equation. We're going to learn how to create the equation from the table. Let's start off with ordered pairs. I have a list of ordered pairs, and from this list of ordered pairs I can either make a graph, a table, or a mapping diagram. Let's start off by making a graph. This is actually pretty easy because all it requires you to do is be able to graph points. I take my first point, -2, -1, and graph it. -1, 0, 0, 1, 1, 2, and 2, 3. Now I have enough points to create a line. So I connect all the points with a line, I draw an arrow on either side to show me that this line goes on forever, and I'm done. Now I know I can create a mapping diagram. I take all of my x values, I place them in the left-hand side. I take all my y values, place them on the right-hand side. So then I take each ordered pair and I connect it with an arrow. So -2 goes with -1, -1 with 0, 0 with +1, 1 with 2, and 2 with 3. I connect the ordered pairs. And last but not least, I can create a table. And a table is probably the most easy because all I have to do is basically rewrite the ordered pairs on each row. So I have -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. Now let's start with the table. I want to take that table and turn it back into ordered pairs. And I can do that because I know that each row is an ordered pair in and of itself. So I get -7, 7, -4, 5, -1, 3, 2, 1, and 5, -1. Now I already know how I take those ordered pairs and I turn them into a graph. Plot the points, draw my line, done. And last but not least, I'm going to take each set of ordered pairs and I'm going to create my mapping diagram. I put all my x values on the left-hand side, all my y values on the right, and then I connect ordered pairs with the line. So that tells us that -7 goes with 7, -4 with 5, -1 with 3, 2 with 1, and 5 with -1. Let's start off with a graph now. I want to create my ordered pairs. So I'm going to take points on my graph and I'm going to list them out so I can get my ordered pairs. My first point is -6, -2, -3, 0, 0, 2, 3, 4, and 6, 6. And if you notice, every single one of my points is where my line intersects 2 grid points. It's at the corner of each grid square. Now I can create a table, and that's very easy. List out all my ordered pairs in x and y, done. And then I create my mapping diagram, list out all my x's on the left, my y's on the right, connect each ordered pair with a line. And finally, let's start off with a mapping diagram. I want to take that and create ordered pairs. I take each set of numbers that are connected together from my x and my y and I create my ordered pairs. So -6 goes with -1, -3 with +1, 0 with 3, 3 with 5, and 6 with 7. Now the rest is easy. I take my ordered pairs, I create my graph, and my table. Basically from this whole process, we need to notice that ordered pairs are the key to creating all the different representations of a function. If we can take what we're given and make it into ordered pairs, then we can create whatever we want from the rest.
That's all, folks.